Good morning, students. So, in previous lecture, we have studied about what is the rate of pressure rise, okay, and what is the normal combustion and what is the abnormal combustion, okay. So, in detail, we will see today what is the knock in a sign. That is nothing but abnormal combustion that is takes place in the combustion chamber, okay. So, let us discuss about this knock in a engine. This is very important point. This is very important concept, okay. In examination, always the question may ask on the knocking in SI engine, okay, and what are the different factors affecting on this knock in SI engine. So please see carefully. Before this, you have to show all, you have to see all the videos that are I have uploaded on the Google Classroom, okay. So please go through that videos also. So knock in SI engine. So already today in a previous lecture we have discussed about the normal combustion. So what happens in the normal combustion? Whatever the end charge is available at the end, the flame velocity is that sufficient to ignite that particular whatever the unburned mixture is available at the end, okay, in the forward direction, and that's why there is no backward pressure created in the normal combustion, okay. And this curve, you can see this curve is very normal, right? And that's why this is called normal combustion. So however, if the end charge bb dash d reaches its auto ignition temperature, the charge will auto ignite, leading to knocking combustion, okay. Now let us discuss about this particular graph. What happens in this particular case? What happens, this b dash d, whatever this charge is available, okay, this b dash and d, okay, whatever charge is available up to this particular at the end of the combustion, what will happen? Only some of the portion, that is b dash c, only this much portion is ignited by the forward flame, okay, and due to the normal combustion. But due to some reason, what happens, this c dash d portion, okay, this hatching line, so this particular mixture will not get burned, and this particular mixture reaches to its auto ignition temperature or the self ignition temperature, and due to this, what happens, this particular c dash d portion will get auto ignite, and the reverse flame will get generated, okay. And this reverse flame and the forward flame get collide to each other, or the waves are generated in forward and backward direction. These waves generates lots of, when they collide with each other, they get the pressure is not normal, okay. There is a suddenly rise and decrease, increase or decrease in the pressure. If you see here in this graph, okay, this graph is not smooth here, okay. And due to this, what happens, the sounds are created inside in the combustion chamber, right? Why that sounds are created? Because these waves collide on the walls of the combustion chamber, and some hammering sound is uh, will be heard, and that sound is nothing but your knock, okay. So it is assumed that when the flame has reached the position bb dash, the charge ahead of it has reached critical auto ignition temperature, okay. The pressure variation in the cylinder during knocking combustion, for normal combustion, light knock and the heavy knock respectively, they are shown here. So this is normal combustion, this is for the normal combustion, you can see here. This is for the light knock, you can see here, this is the light knock. But in the heavy knock, if you see here, the pressure rises are very much sudden, okay. You look at this, this is very straight line, right? Okay, and this is the difference between normal combustion and heavy combustion or the heavy knock. So because of the auto ignition, another flame front starts traveling in the opposite direction to the main flame front. When the two flame front collide, several pressure pulses are generated. The pressure or the presence or the absence of the knocking in combustion is often judged from the distinctly audible sound. A scientific method to detect a phenomenon of knocking is to use a pressure transducer. Okay? If you want to measure the phenomenon of knocking, then just what you have to do, you have to use the pressure transducer. So from that you can easily identify. Knocking is very much dependent on the properties of fuel. if the unburned charge does not reach its auto ignition temperature, there will be no knocking. So if you want to avoid the knocking, what we have to do? If you want to avoid the knocking, what we have to do, whatever unburned charge is available at the end of the combustion chamber, that should not reach at its auto ignition temperature. Okay, and how this can be achieved, that we have to see in the next points. Next, okay, this is the first method. We can, by using this method, we can use the we can reduce the knocking. Second method, if the ignition delay period, okay, if the ignition delay period, that or the time required for the flame front to burn through the unburned charge will be short, then there will be no knocking. Okay, that means the ignition delay period should be longer. Okay, ignition delay period means what? The time required to reach the time required to reach its auto ignition temperature. So if the time required to reach the auto ignition temperature is more, so what will happen? So more time will be required to reach the auto ignition temperature, and up to that, during that period, flame in the forward direction, which is traveling towards the unburned charge, this will definitely eat or burn all the unburned mixture that is remain at the end. So ignition delay period must be very much higher, so that the time required for the flame front to burn through the unburned will be short, and then there will be no knocking. Okay, hence in order to avoid or inhibit detonation and a high auto ignition temperature, a long ignition delay are the desirable qualities of the SI engine fuel. Okay, remember this. This is very much important. Okay, how to avoid the detonation, that also we have to write. What are the effects of engine variables on the NOx? Okay, so this is again a very important concept which can be asked in the examination. Okay, so what is the effect of temperature? First, let us discuss about the effect of temperature. So what reduced temperature of the unburned charge reduce the possibility of knocking by reducing the temperature of the end charge for auto ignition. So whatever temperature is available at the end of the combustion chamber, if that temperature is reduced, so there will be no knocking generated inside the combustion chamber. What is the effect of compression ratio? So increase in compression ratio increases the pressure and temperature of the gases at the end of the compression ratio and increases the tendency of the knocking. So when you increase the compression ratio, definitely it is the favorable condition for the unburned mixture which is available at the end, and that's why knocking may happen. So we have to keep this compression ratio as less as possible in case of SI engine. Okay, effect of engine variables. Again, the next is effect of density. So reduction in density of the charge tends to reduce the knocking by providing lower energy release. The overall increase in the density of the charge due to higher compression ratio increases the free flame reactions in the end charge, thereby increasing the knocking tendency of the engine. Remember, so we have to decrease the density. Okay, if the effect the density decreases, then definitely what will happen? It will release the less lower energy, and therefore there will be no chance for the auto ignition. Inlet temperature of the mixture. Okay, increase in the inlet temperature of the mixture makes the compression temperature higher, thereby increasing the tendency of the knocking. Okay, so inlet temperature increases, that means knocking increases. Further, volumetric efficiency will be lowered, and hence a lower inlet temperature is always preferable to reduce the knocking. Okay, now next is mass of inducted charge. How much amount of mass we are taking inside the combustion chamber, how this happens. Reduction in mass, if you reduce the mass, okay, of the inducted charge into the cylinder by throttling or reducing the amount of supercharging, reduces both the temperature and density of the charge at the time of ignition. This decreases the tendency of the knocking. Okay, so mass of inducted charge must be less. Okay, temperature of the combustion chamber walls. Now definitely what happened? To prevent knocking, the hot spots in the combustion chamber should be avoided, right? Since the spark plug and the exhaust valve are the two hottest part in the combustion chamber, the end gas should not be compressed against them. Remember this point. Okay, so while designing the combustion chamber, we have to keep in mind that this particular spark plug should not be at the towards the exhaust side. Okay, so it should be away from that, because this exhaust valve and the spark plug, these are the hottest regions or hottest parts inside the combustion chamber, and which may lead to auto ignite of the onboard mixture which is available at the end. Next variable, retarding the spark timing. So the spark timing, how this particular spark timings affect on the knocking, let us see this. So retarding spark timing from the optimized timing, that is having the spark closer to TDC, the peak pressures are reached further down on the power stroke and are thus of the lower magnitude, and this might reduce the knocking. However, the spark timing will be different from the MBT timing, affecting the brake torque and power output of the engine. Okay, so the MBT, maximum power, maximum brake torque. Okay, we can say spark advance, and this is the relative torque. Okay, so this is the maximum brake torque point. Okay, now power output of the engine. Let us discuss about the next point, that is power output of the engine. So a decrease in the output of the engine decreases the temperature of the cylinder and the combustion chamber walls, and also pressure of the charge, thereby lowering the mixture and the end gas temperatures. This reduces the knock. Okay, so okay, remember, if you decrease this, then definitely you will have less knocking. Turbulence. Turbulence depends on the design of the combustion chamber and the engine speed. Increasing turbulence increases the flame speed, reduces the time available for the end charge to attain auto ignition conditions, thereby decreasing the tendency to knock. Okay, remember this. What will happen? Due to increasing turbulence, what will happen? The flame speed increases, and as flame speed increases, it will reach up to the end mixture. Okay, engine speed, again it is same as the turbulence, because engine speed depends upon the turbulence. So when turbulence increases, means engine speed increases, and definitely it will again good for the knock, is the knocking tendency is reduced in this case, higher speeds. Flame speed also increases due to this engine speed. Flame travel distance, the knocking tendency is reduced by shortening the time required for the flame front to traverse the combustion chamber. That is engine size, combustion chamber shape, and the shape spark plug position are the three important factors governing the flame travel distance. Okay, so remember, while designing the combustion chamber, you have to keep this particular distance as less as possible, so that flame will reach to the other end very easily or within less period of time, so that knocking will avoid. That is again engine size. The flame requires a longer time to travel across the combustion chamber for larger engines. Therefore, larger engines has a greater tendency for the knocking, and then the smaller engines, since there is more time for the end gas to reach the auto ignition temperature. Hence, an SI engine is generally limited to size of 150 mm bore. Okay, remember this. Combustion chamber shape. Generally, the more compact the combustion chamber is, the shorter is the flame travel and the combustion time, and hence better anti-knock characteristics. So combustion shape must be as compact as possible. Okay. Next is the combustion chambers are made up of spherical, or the possibly to minimize the length of the flame travel for a given volume. If the turbulence in the combustion chamber is high, the combustion rate is high, and consequently combustion time and the knocking tendencies are reduced. Hence, combustion chamber is shaped in such a way that as to promote the turbulence. And the next is location of the spark plug. In order to have a minimum flame travel, the spark plug is centrally located in the combustion chamber, resulting in the minimum knocking tendency. The flame travel can also be reduced by using two or more spark plugs in case of large engines. Remember this. Okay. So these are the different engine variables that are affecting on the knocking. Now there are some composition factors which affects on this knocking, such as fuel air ratio. This is a mixture of fuel and air. Okay. So the flame speeds are affected by the fuel air ratio, Also, the flame temperature and the reaction time are different for different fuel air ratios. Maximum